software development life cycle, then why DevOps, what DevOps, DevOps life cycle, and then finally DevOps tools. So this would be a very short course on the basics of DevOps and software development. So I hope I'll be able to clear your basics on DevOps concepts. So let's quickly begin with chapter 1. Hello guys, myself Jatin Agrawal, and let's quickly begin with chapter 1. What is software development? So basically, the process of planning, building, testing, and maintaining various software applications is known as software development. The process is also known as software development lifecycle. Now, whether we realize it or not, software development is an essential part of our everyday lives. Software in our car, in our phone, in our fridge. So it's kind of everywhere. And it's not only going to become more ubiquitous as time goes on, but with this increasing demand for software comes an increase in demand for software developers as well. A software developer is someone who designs, creates, tests, and maintains the software that we use every day. And while the demand for software developers is really high, similarly, there are still a lot of misconceptions about what it takes to become one. So let's talk about the common myths about software development. First myth, software development means writing a lot of source code. Indeed, typing code is important, yet there are other plenty of activities involved in this process. Just to list a few: meetings. These may eat up a significant portion of a software developer's workday. Whether we like it or not, meetings will happen. Second one is communication. So you'll need to respond to emails, phone calls, messages on Slack, Teams, or whatever it is. Also, agile methodologies require a fair amount of communication between team members. Third, quality assurance. So what actually means is that you will have to implement and execute all kind of tests. For example, unit test, performance test, usability test, and so on. The fourth one is documentation. Writing and reviewing documents is also an integral part of a software developer's work. So for instance, you'll need to document your code. It may sound boring at first, but code, comments, if done right, are one of the most useful resources produced by developers, because trying to find out what a code actually does can become a daunting task if there are zero comments. So as your job responsibilities grow, you'll need to write various technical documents like developer guides or design documents. So now let's move to the myth number 2. Softwares can be easily estimated accurately. Software estimations are essential since both the customer and the development team must make decisions based on it. Predictions are usually only accurate when making near-term forecasts. Unfortunately, in the case of software projects, we are asked for long-term estimations. Although everybody admits that estimations are inaccurate, will suffer the consequences of missing our deadlines. So these consequences include, but are not limited to, loss of credibility, poor morale, low quality software, and etc. And even if the project failure when estimations are consistently off and the customer has completely lost faith in your team's ability to deliver. Now, myth number 3, the mythical man moth. It represents the idea that adding people to a development team makes it more efficient in a linear fashion. In fact, adding more programmers to a project falling behind schedule delays the project even further. Why is that? Because complex projects cannot be split into discrete tasks that can be worked on without communication. With every newly added developer into the team, the communication overhead increases. Also, the newcomers needs time to learn about the basics of the projects. Thus, they'll ask more insights who in turn will spend less time developing the product. So all of these add up and consume an even larger quantity of the available time. So the output of the team decreases further with every newly added programmer. Now moving to the next slide. Activities involved in software development. First one, collect and analyze requirements. So requirements can come from a customer, colleague, or from another team. Depending on the stakeholder, requirements can be well defined, vague, or utterly misleading. If a need is well understood, chances are the client eventually receives what they wanted. Next activity, validate ideas and feasibility studies. Regardless of whether all requirements are well defined and crystal clear, some may be impossible to implement. Technology constraints, lack of expertise, resource issues, and other foreseen problems may prevent us from delivering the product. Thus, it is imperative to double check whether we can achieve what the stakeholders expected. Third one, design and prototype. So the architecture of a software product or system is its blueprint. It defines the static structures and the interactions between the components. Creating prototypes and doing proof of concept work is sometimes also required, especially if the team has no prior experience with the given technology. Fourth one, write code and tests. The implementation phase should also involve writing unit tests and sample applications. Thorough testing ensures that severe bugs don't slip through. Testing is a crucial part of the development process. Nobody can guarantee quality without validating software. Fifth one, write documents and guides. So for software products, there can be many types of documents, design documents, test scenario descriptions, API documentations, and a lot more. So not all software projects require all of them. And the type of documentation also depends on the development methodology of choice. The last activity, release, support, and maintenance. Once software is tested and ready for the release, there are still a lot of other things to watch out for. Depending on the product, there may be marketing, packaging, distribution related tasks, and many others. Resources should be allocated for support and maintenance as well. No software is completely bug free. Besides, customers may ask for improvements and enhancements over the time. Now, the bottom line is a developer needs to handle various tasks. Writing code is just one small part of it. So that's all for the chapter 1. I hope you guys have understood what is software development and basics of it. So I'll see you guys in the next video. Thank you. Hello guys, welcome to chapter 2, Software Development Lifecycle. I'm your author Jatin Agrawal and let's begin with this new chapter. So basically, what is SDLC? SDLC is a framework, process, model, guidelines, or approach which describes the activities performed at each stage of software development project. So these are all the same and means the same. It's just a case that different people are using different words interchangeably in the upcoming sessions. So I might refer it to as SDLC process or SDLC framework or SDLC model or guideline or approach, whatever. Basically, this framework processes models. Guidelines are the time-tested solutions to the past problems which people were encountering during software development, and some people documented it for others to follow to avoid those problems in future. So on a high level, the SDLC models looks like this. It is composed of 7 stages or phases. So the first one is analysis and planning. In this first phase, customer will analyze their teams working, company's processes and come up with the projects which will ease their work at this phase. Customer will have project plan, requirement and their budget. So the second phase is requirements phase, where customers will hand over these requirements or project plan to the project team who will be going to work on that project. Now the third one is design and prototyping. In this phase, the project team will go through the requirement and come up with the smart designs and prototypes. The fourth phase is software development, where both customer approval on design and prototyping facing project team will start coding those requirements. Fifth one is testing phase. In this phase, the coded functionalities will be tested not only by the testing team against the defined requirements. The sixth phase is deployment. Once testing is completed, application will be deployed to server, means it is released for the customers. The seventh phase is maintenance and update. Post releasing of the project, they will keep on discovering new functionalities or bugs in the existing functionalities. These new use cases are the requirements and bugs will be provided to project team for fixing. So bugs would be fixed and the updates will be released in the application as a new version. We'll see each and every phase in depth in the upcoming slides. So let's take a look of phase 1 in depth. Once customer or stakeholders request for the project, the first step of SDLC will be initiated, that is analysis and planning. So in the first phase, things would be analyzed. Ailment of the project, understanding whether the project aligns with your company's larger vision and goals. Next, resource allocation. So resource availability and allocation is the company that has all the necessary tools. Teams are skilled people who can work on this project. Scheduling. Scheduling is nothing but assessing your current bandwidth to understand whether you will be able to deliver the project in the prescribed time frame or not. Cost estimation. Evaluating the total cost will completion of the project. So in this phase, project team and all the impacted teams, departments like security and operation will be consulted as well. After all of these 4 analyses, a high-level documentation is being made, which is nothing but scope of work. It is a plan that details out what is being built and what you will see at the end of the completion of the project. So it defines the project specific activities, deliverables, and timelines for the vendor providing services to the client. Now phase 2, requirements. Requirements are gathered from the business user by scheduling calls, meetings, workshops with them. Or in some companies, there will be defined templates. Those will be shared with business team to fill and they will share it back. Now let us take a look at the next question. Who will be the part of meetings or workshop? Business users from business side or project team side, project manager, etc. So these meetings are kind of brainstorming sessions which involve identifying the use case by answering the common questions for each use case, like how the existing system is working, means understanding the existing way of operation. Second, who is going to use this project, means finding the actors in the application. Third, what is the input and output needed for? Do you need to integrate it with any third-party APIs or tools? How to handle the security and privacy in the application? And sixth one, what are the limitations we have once this meeting or workshop is over. So these are the requirements. So once we have answers to all of these questions, then business analyst will prepare the detailed software requirements specification documentation, which is also called as SRS. So basically this SRS documentation will have all the functional and non-functional requirements as defined here. So functional requirements specifies or describes what the software application or product should do. They are basically the requirements stated and demanded by user, which one can see directly in the final product. Unlike the non-functional requirements, for example, for our daily needs companies, the internal employees portal project functional requirements can be first login form for new employees to log into the application, second web page with form to fill new joining details and etc. Now let's see what non-functional requirements are. So non-functional requirements are basically the quality constraint that system must satisfy according to the project contract. In short, it describes how the software application product needs to behave with respect to performance, response time, accessibility, scalability, availability, maintainability, and extensibility. So coming back to our daily needs, it can be internal employee portal, it can be every page of application, then it can be the applications which will be accessible in the browser, and it should be available all the time. All of these can be considered under non-functional requirements for our projects. So once we get the clarity on all of these requirements, then we can start with technical requirements, where we define the technical stack like database which we can use to build this project. Next, let's move to phase 3, design and prototyping. So here the documented requirements from the software requirements specification document will be converted into wireframes and prototypes using online tools like Figma and InVision, which means input to this phase is to the SRS document. So developers, lead developers and architect people are directly involved in this phase. This phase is all about how you design your application end to end. It can be high level design or low level design. So high level design concerns the entire system. It describes the overall description, architecture of the application. It includes the description of the system architecture, database design, data flow diagram, brief description on system, services, platforms, and relationship among modules. It is made by architects. Low-level design describes a detailed description of each and every module, means it includes actual logic for every system component, and it goes deep into each module specifications. So for example, during coding UI component, low-level design of UI will involve which design patterns to be followed, which classes to be created. So it is usually made by the lead developer, the decisions I mean. So people in this step will get a glimpse on how their requirements will be shaped as a final product. So by people I mean the customer or the business people. So they will review these and share their feedback based upon that. Also, the project team will decide how many different application environments they need: dev, prod, QA, SIT. Basically, dev environment is for developers and the stage is for business users to carry out UAT testing. Prod is for production. So that is the final environment at the end of the phase. So the prototype designs and wireframes, these things will be used by the developers for coding in the next phase. Phase 4, software development. At the start of the development phase, there is a developer's manual which is prepared which will have all the rules, good practices, naming conventions to be followed. All of them are listed, and entire coding should adhere to this manual. It will help to bring consistency in the coding even though multiple developers working on the same project for building a clean and scalable application. So you need to follow the object-oriented programming concepts, design patterns during coding, and the code written will be reviewed by the colleague, leader. However, it is called as a peer review. Sometimes you might see in where the developers don't prepare a change log document which will have details about what on changes you carried out for a specific requirement. One point to note here is the phase. This phase is crucial piece where maximum portability of derailment of schedule and estimates can happen. Asking for some clarifications on requirements in this phase is a deadly affair. Output of this phase is fully coded and working functional requirements. This record is deployed to the environment where developers will verify the working of the code against the requirements. If everything looks good, then the code is moved to the next phase, and then the quality assurance testing is carried out. So this is what happens in software development phase. Moving to next one, testing. Testing is the most important phase in SDLC lifecycle to deliver the quality product when you are developing or loading the modules which are part of an application. You can carry out testing side by side, but once your whole coding is completed, you need to hand over the final software to the testing team where they will carry out the quality assurance testing. So the first one is functional testing to test all the functionalities. Integration testing to test integration with third-party system tools and services. Performance testing. The performance of the entire application load testing. Testing application by simulating multiple users accessing the program concurrently. Penetration testing. This testing is done by simulating the cyber attacks on the system and so on to make sure the software meets the functional and non-functional requirements defined in the SRS interface. The bugs with this testing team will raise needs to be logged, and the developers will fix those and deploy again. So this phase do need subsequent deployments. Now moving to the next step, deployment. After so much of effort spent in each and every step of SDLC lifecycle, it is finally the time to launch the software for the users. So this is called as production deployment stage, where all your code, build package code, which you move from there to here, will be deployed to production. All this process of deployment is automated using application release automation tools like DevOps, and there are many others. So there is no manual intervention required in this step. So the deployment activity will be taken care by a separate DevOps team in some companies. You might also see a change management team prior to the deployment to the main server. So this request for change is also involved the detailed backout plan or rollback plan in case your code is not working as expected in production environment, then how to restore the application to the previous deployment. This is all covered in the backout plan, and this needs to be approved by the change manager who will assess the impact cost for this deployment and finally approve it once the entire change is approved. Then, as per the schedule, the application will be deployed to the broader environment and released to the business users. So generally there is a hypercare period of 15 days and it can vary from company to company. So during these 15 days, if there are any issues getting reported, then those needs to be addressed at immediately. as part of hotfix, which is another small deployment followed by the main deployment. So the main output of this phase is the fully working software as per the requirements in the prod environment. So this is what happens in the deployment phase. Now moving to the phase number 7, maintenance and updates. So once the software is launched for all the business users, means post-production deployment, the maintenance and update phase will stop as people will begin to use the software. So they will find issues or bugs over the time. So they will come up with new features which will add value, or they might ask you to make the changes in the existing functionality. So all these feedbacks will flow to the project management team in the backlog section. So the project management team will have a periodic meetings with business team. In that, product management team will get these items prioritized as per the value of benefit. So basically, there is a standard procedure defined for raising the application issues. So you might have heard of ServiceNow or Remedy. So where the business users can log the ticket with the detailed replication steps. So these tickets will come with a priority and that has a service level agreement. So the time span of the service level agreement will be defined at the start of maintenance and upgrade. So it is a mutual agreement between the project team and the business team. So we have certain levels in the SLA like low, medium, high, critical. So for example, low would be a time of 2 weeks, medium would be 5 days, high would be 1 day, and critical will be 3 hours. So basically what it means is, let's say there is an incident which is logged, and if it is of critical priority, then you have 3 hours to address the issue. If not, then there would be a SLA breach. So in this phase, usual server updates like operating system update, application framework upgrade will be carried out and released to address the new features requirements. So this is what happens in the maintenance and upgrade phase. Now moving towards to the benefits of using SDLC. So it makes it clear what is the problem you're going to solve or what is your goal. It is very easy to derail or divert yourself when you're working in a big project with SDLC. You can clearly see the goals and the problems as well. So each team will have a clarity on what role they will be performing. Next is common vocabulary for each step. When there are many people involved in the project, it is easy to get confused in a different language used to describe the same thing. So to avoid this, SLDC framework, common vocabulary to be followed by everybody from start to end. Next, project tracking and visibility. So providing a mechanism for tracking and increasing the project progress to all stakeholders as you're following the SDLC defined plan. It would be really easy to track where you are and how much yet you are about to cover. And at any point of time, stakeholders can track what is the current status of their project. So this will give them more visibility about what is happening around the project. Improved product quality. At this stage, the output generated at each stage will go through the quality control defined at the stage. So this will help to build a high quality product at the end. Increase the development speed. Since you're following the SDLC deployment plan, you can increase your deployment speed as well. Next, decrease the project risk. So usually whatever can go wrong in the software development phases is already being handled by the SDLC process. So we might see the decrease in the risk. Next, and the last one is decrease project management overhead. As the clarity is present since the beginning, between each and every team member about what each one will be playing a role as. So no special requirements or efforts are required here. Plus, there is also a cost saving during the development cost of software, which is directly proportional to the hours spent as SDLC. So it gives you the optimized plan to complete the project. So then the project team can reduce costs during the deployment, and all are these the benefits that will be SDLC. So here we come to the end of this chapter. So I hope you are clear about the SDLC concepts, the 7 phases, what each phase does, and what is the benefit of using SDLC. So thank you guys, and I'll see you guys in the chapter 3. Hello guys, welcome to chapter 3, traditional models for SDLC. So let's get started. Whatever we have seen till now about SDLC, those are the guidelines and the best practices to be followed. And various teams started following those steps as well. But as it is said that each project is unique and needs to be handled in a special way, so fitting every project in the basic SDLC guideline is a top job. So things started experimenting based on their project requirements, circumstances, complexities of the project team plan, and during doing all this, they decided what to give value and what not. So they did permutations and combinations of SDLC guidelines and added some extra practices wherever required in doing, and they came up with a different SDLC model like waterfall, incremental model, iterative model, V-shaped model, spiral, agile, and there are a lot more available nowadays. So we'll be taking a look at all the top 7 models which are generally used everywhere. So these models are nothing but a time-tested solution to the problems. So when we go through these models, you'll realize that these models are composed of same steps as of SDLC. But the difference lies in the way the steps are followed during the process and what things we value during the process. So let's begin with the first one, waterfall model. So waterfall model is the first and oldest traditional software development model. It is a simple SDLC model because it is using the steps as DLC as in the sequence. Hence, it is also far less a linear sequential lifecycle model. It is very simple to understand and use. So this is how the typical waterfall model diagram looks like. So you can see the first phase is the requirements phase, then the specification phase, then the next software design phase, then implementation, then testing, and last maintenance and update phase in the waterfall model. So each phase must be completed, means whatever goal needs to be achieved in that phase needs to be achieved and completed and signed off before the next phase can begin. You can see that there is no overlapping in the phases here. So the output of one phase will be the input for the other. Phase means if one phase is not completed, then the next phase will not start at all. No confusions, right? So from this we can say that it is a software implementation model where each step output is inspected, verified, approved, signed off, and then it is sent to the next phase. We have understood the waterfall model now. Now let us see where can we use waterfall model or which type of project can be the best fit for this model, plus which requirements are basically fixed and well documented. It is obvious if your requirements are not clear and fixed, you cannot move to the next phase of SDLC as you are stuck there itself. Project for weight requirements are very clear, fixed, can be a government project. Most of the cases, government projects requirement are fixed and well documented. Second, application is not complicated and big. If the application is complicated, it is tough to get full clarity on the requirement and then the design as well. This can again go against the waterfall model type project, which is a sharp, short project with clear requirements out of best fit for waterfall model. Now, if you have requirements clarity and you don't have the required resources to move forward with the design and development phase, then you cannot use the waterfall model in that case. So the next one is mission critical projects where there is no tolerance to any errors or failures at any step post goal of the project. However, if you have agile model, then agile model is about providing quick fixes. It has a varying level of tolerance for bugs and bugs reported. So both goals is accepted in agile model, and agile model will be seeing in the upcoming slides to avoid bugs in waterfall model at each step. The output is verified and validated. So waterfall model can be used in projects like e-commerce supply chain, application payment gateway, and this application flight control system stop reading project means which on mission critical projects there are waterfall model can be a best fit as a DLC model. Now let's take a look at the pros and cons of waterfall model. Pros plus simple and easy to understand and implement. We have seen no complication exists during implementation of waterfall model. Second, easy to manage, tens of deliverables at each step is fixed. Term phases are completed one at a time and it is good. No mess up with the phases here could work well in project ways. Scope is firmly fixed. Scope is firmly fixed, quite clearly defined stages or phases. Next, it has a good visibility on the progress of the project. Next one is process and results are well documented. Now let us focus on some of the cons of waterfall model. So no working software in early stage means working software customers will see late in their lives that this is the biggest drawback of this waterfall model. And there is no concept of MVP, that is the minimum viable product in this model. Second, managing the activities within the phase means tracking progress within the phase is to cut. Since phase completed one at a time, you might see some underutilization of team members. For example, during software development phase, they still will have no much work for not suitable for projects where the requirements are. So people who are model for long and ongoing projects because in long term there is a risk of requirements. The last one is there is no scope change or scope adjustment possible in waterfall model. There are some of the pros and cons of the waterfall model which we have just now discussed. So now let's move on to the model number 2, which is incremental model. Now before understanding the incremental model, let us see what problems existed in waterfall model. So the first one was you were developing everything at once and then pushing everything to testing. This can be overwhelming for some teams since testing is done at the end. One defect found in the testing might not need many changes in the application for its fixing. Second problem is when development phase is going on, there might be a case where some testers are unoccupied or underutilized to address all these problems. Some set of people with the waterfall model like this and quality as an incremental model. The name itself says incremental. It means delivering something piece by piece in increments. In incremental model, similar to waterfall model, requirements will be gathered in one go, but next phases will be run on. The simple small set of requirements are for some features. Each much small sector with progress will through design and download made testing, implementation and billions will be made for that part and pretty. So in such incremental way, you keep on adding features or parts to the existing systems. So in a nutshell, incremental model is where you build the overall solution in part. But at the end of each phase or increment, you do not have anything that can be reviewed or paid back. Provided on means whatever you build is not something which can be given to customers to get his feedback over it. You need to wait until the final stage for the incremental process to deliver the final product. Now, since we have understood the incremental model, now let us see when and where can we use the incremental model first. First one, products where a requirement of the systems are clearly understood, and this is obvious. If the requirements are clear, then small incremental planning can be done for that project. Second, when you have the resource crunch and you want to utilize the resources to the fullest here, at the time you just need enough resources to work on the single increment so it can be used in projects. Third, scope changes to some extent. Now let us take a look at the pros and cons of incremental model. Firstly, the software can be developed quickly, means we can save time here compared to the waterfall model. Second, there is a scope for changing the requirements, so you can see some flexibility with respect to requirements and scope. The errors can be identified early as we are initiating the testing activities of the part in the early period. Now, moving towards the cons, the final product for review to the customer will be available at the end of the last increment. So you will get the late feedback from the customer. Second requirement of scope in the middle can cause you to spend more time on incorporating that, as it might have impact on already busy parts. Moving towards the third model, iterative model. Before moving to the details, let's understand the problems which we were having with the previous models like waterfall and incremental models. So the main problem was what the customer aims to get product early to provide the feedback. He needs to wait until the end to provide the feedback, and sometimes this wait can be so long that by the time the requirements might have changed completely and whatever you hurdle up is completely obsolete. So some people seen this problem and they came up with a new model called iterative model which tries to solve this problem. So as the name itself says, iterative means iterations simply means the reworking and usually means refining something repeatedly until satisfied. This is how the iteration of model diagram looks like. So in a trading model, you will gather all requirements which how customer might not have one requirement, but just enough basic requirement. That is also fine in this model. Out of all the requirements, you will select the enough requirement which will help to deliver the MVP, that is the minimum viable product, that is a small working prototype of the software. So this happens in the planning and analysis phase. So those requirements then more through design development testing creates this somewhat similar to incremental model. So many people use incremental and iterative term interchangeably, or you might see people with both models as a single model and call it as incremental and iterative. So once testing is completed, the code will be deployed and released to a customer now. So customers having something here to review and provide the feedback. So customers will provide the feedback, and if the customer feels the product is turning out properly, he will provide more requirements along with the feedback, and again this feedback and requirements will go to the next cycle, next iterative cycle. So with every iteration we will keep on adding features to the existing product and keep on improving the existing product. So now let's see when and where the iterative model can be used. Firstly, for a startup project, are broad-based companies where you need to deliver basic working software as early as possible so that minimum functionality can reach out to end users and companies that all need to wait till the final product built. Second, when you don't have clarity on the product requirements at the beginning. And third one, when you don't have the resources available. So there are some cases if your project falls into, then you should go for it. Now let's take a look at some of the pros and cons of this model. Workings of software will be delivered in the early stages, as we have seen at the end of every place, and customer will have something to review. Second, early feedback can be provided on software, so there is a room for improvement. Total flexibility with respect to scope and requirement for core startup product companies, so that they can decide in early stages to continue with the product or cancel the product. So this model also helps in decision making process. Now let us take a look at some of the cons. First, requirement changes can badly impact this model. For example, if you've got a new requirement in it recently and these requirements impact something built in iteration 1, then in such cases impact will be much more. Next, technology changes can make the previous record unusable. So for example, if you've got requirements which can be done by specific technology only, then you might need to rebuild your already developed code to the specific technology. But more management attention is needed. This is obvious since for each iteration we need planning and execution. Next one, for system architecture, arc design issues will come as not all requirements are gathered in the beginning of the first cycle. Next one, iterative model will end up costing more as the requirements keep on tending. Sixth, you might not have clarity on the time to completion of the project as you keep on accommodating the customer feedback at each stage. So these were a few pros and cons of this model. Now let's move to the next model, V-shaped model. So before moving to this model, let us consider a scenario. So let's assume a team is working on a big project using the waterfall model, and a lot of time went in developing the project at its integrations, and finally development team declared that the project is ready and is handed over to the testing team. Distinctive started testing and they found one defect in the application. Post analyzing the defect by the development team, they found it needs a big change and they might need to rework on 50% of the code, and will be with this kind of scenario will increase the cost of project and hamper the timeline of the project as well. The team has realized this problem and they came up with the V model, where they have given importance to the strict verification and validation at each step of residency. So V-shaped model is an extension of waterfall model, but here the waterfall model you can see in V-shape. So this is how the diagram looks like. We also know that verification and validation model, just like the waterfall model, the V-shaped model, the V-shaped life cycle is a sequential path of execution of processes. Each phase must be completed before the next phase begins. So the first phase is requirement gathering, then system design, then the architecture design, module design, and then the center phase is accordingly. Once coding completed, testing phases will start in sequence like unit testing, integration testing, system testing, and acceptance testing. So the left hand side activities are the development activities and the right hand side activities would be the testing activities. So for each verification activity, there is a associated validation activity as well. This validation activity planning will start when we are in the verification phase. So for example, when we are in the requirement gathering phase, where we are gathering the requirements about what systems to do the verification activity will be the requirement to review, and the validation activity can be creation of user acceptance test cases. So accordingly, when we are in system design phase, the verification activity can be design reviews and validation activity can be the creation of system-based cases. So when we are at the architectural design phase, where review is an activity, can be architectural review, and validation activity can be creation of integration. So when we are at the modular design phase, verification activity can be low-level design review, and validation activity can be creation of unique test cases for each model. This way, for each phase, we have verification and validation steps which are strictly followed in this V model. Now, let's take a look at which projects are the best fit for this model. So this model is suitable for projects which are small and medium in size, where requirements are clearly defined and fixed. And this is obvious as we are gathering the requirements at the beginning itself. Second, the medical devices industry software projects are using the V model the most. This makes sense. The patient and medical professional mostly use an accurate information and resources. So for them, verification and validation results are of utmost priority. Next, card projects where compliance to regulation and law and accuracy are the most important feature of the program. Such projects are the best fit for V model. Government projects are one among them, where compliance and audit are mandatory activities. So there are some of the project cases where you can consider using this V-shaped model. Now moving to the pros and cons of this model. So let's start with the pros. This is a highly disciplined model and phases are completed one at a time. Second, worked well for smaller projects where requirements are very well understood. Third, simple and easy to understand and use. Now let's see the cons. So some of the cons of V-shaped model was not a good model for a complex project. Second, what a model for long and ongoing projects. At the beginning, there is no scope of requirement and hence not suitable for projects where requirements are changing. So this is obvious. If requirements are changing, you cannot plan the verification and validation processes. Next, for once an application is in testing status, it is difficult to go back and change the functionality, because if you change functionality, then you might need to iterate again through verification and validation steps. So these were some of the pros and cons of using V-shaped model. Now let's move ahead to spiral model. Now before jumping on to the fifth model, let's see the problems of the previous models. Let us assume that Tim is following the waterfall model and they have a requirement to build a third-party integration of new feature, which is completely new, and that requirement was accepted in the beginning. Now, in the later stages, it was observed that Tim cannot believe that integration or a new feature. In such cases, there can be many reasons like technology or stack is not compatible with the existing technology, or there can be compliance issues, and you would be seeing that these kind of cases happening in your company as well, where in the beginning your project manager committed something and later on the requirements change. So it is a typical case. This kind of risk can come up in later stages. So how to handle these kind of issues in a systematic way is not uncovered by previous models like waterfall, incremental, iterative, V models, and etc. Second issue is in the V-shaped model, where we used to gather all the requirements at the beginning and then carry out the verification and validation at each stage to avoid the risk of identifying the bugs or defects in the later stages. But here, changes in the requirement was not allowed. So this was the second problem with the model to handle this problem. Some people came up with an entirely new approach and named it as a spiral model, mainly targeted to avoid the risk in the software development process or highlight the risk in the early stages. So at the same time, it also provides the flexibility to requirements and scope changes. But the main focus of spiral model is the risk assessment in the beginning. So this is how the diagram looks like. So there are 4 sections in this diagram. First one would be planning and determining the objectives of each cycle. In the spiral starts with identification or purpose of the cycle, then the various alternatives that are possible for achieving the target and the constraint that exists. So it will be the requirement gathering periods altogether. Second phase is risk analysis. This is something which is main phase of spiral model in this phase, where all the requirements are analyzed and the requirements which are new complex needs, third-party integrations are identified and small prototype of such requirements are made to demonstrate whether it is possible without any issues or not. So if the team sees any issues in the prototypes, then here only means in early stages the action can be taken on that requirement by either cancelling it or amending the requirement. So if you see, this risk here is to handle at early stages as compared to other models in the later stages, and this is the speciality of spiral model. If the team sees no issues with prototype, then the next phase, that is product development, will start, which is mostly similar to waterfall model, where design, coding, testing and implementation means deployment will be carried out. The next phase is of evolution phase, where customers will review the product deployed and share it back, and then the new requirements with the project team would be shared. And again, this final model will interact. So each parallel loop is one cycle of phases of SDLC processes or one version of your software. So the exact number of parallel loops is unknown and can vary from project to project. Radius of the spiral is supposed to represent the cost of the project supply. It gives you the indication of your cost, and angular dimensions represent the progress made in the current phase. Now let us talk about way to use this model. First, projects which has a medium to high risk project can use this model. We have seen spiral model is about risk assessment, so high risk projects can go for this model. Next, project for which risk and cost evaluation is utmost priority when requirements are changing and releases are required to be frequent. So this is another speciality of this model, as it works in incremental and iterative way and provides flexibility for the requirements and scopes. Adjustment for spiral model is highly used in companies where they will assess the risk in the beginning and initiate the project activities accordingly. Now let's take a look at the pros and cons of this model. Pros. So first one is spiral model mostly concentrated on risk analysis. The second most useful for large and high risk projects per spiral model used. If requirements changing frequently for users, see the system early. Customer can provide the feedback in the early stages. The cost estimation becomes easy as prototype building is done in the early stages before development phase begins. And this is obvious. If you build some prototype, then you have good idea on how much effort needed to be the main project. Next, there is always a space for customer feedback. Now let us see some of the cons. First, for risk analysis phase, we require the expert person to make analysis. If your team doesn't have any expert, then you might find it challenging to analyze the risk. Second, it can't be used for small projects, as for smaller projects doesn't involve much risk in spirals of their model, and it is not advisable for the same small projects. Also, it might cost them a lot. Now, talking about duration, it will be costing infinite to finite because of the spiral feature, and this is obvious since all working in incrementally to do with duration and cost, which cannot be predicted. For some, buying prototype design is not so good, so it was a bad image to the customer. Next one is, it is a risk of not meeting the schedule or budget in the deadline. So these are some of the pros and cons of using spiral model. Now let us see the sixth model and the last one, agile model. As the name itself says, agile means versatile or adaptive. If you see the diagram, it is much more extending the waterfall model by taking the physics as is from it, and iterative and incremental model by taking the base of operations from it. So agile model break big requirement into smaller tasks, and big small task features are part of the time and build up part by going through all phases of SDLC. This way, the final product will be iterative using the iterative cycle and incremental cycle as well. So this iteration can be of 1 week or a week longer. So the splitting of big project into small requirements and further requirement into small tasks help a lot in minimizing the risk and overall project timeline for smaller chunk of requirements. So the iteration will be one iteration will help planning phase, then requirement phase, then designing, development, and testing phase here. So at this stage, if the develop part of product meeting the expected results, then it will be deployed and result released to the customers, and then the customer will share the feedback and planning will be initiated. So this is all about improving it and building the final product till it meets the customer needs during each iterations. Customer means product one are supposed to work with the development team to clarify their concerns on the way. So this is how the agile model is interpreted from the diagram, but I will say that agile is not just what you see in the diagram, it is much more than that. It is bringing all together a different mindset of software development lifecycle, and because of that, it is the most popular and mostly used model nowadays. Agile believes that every project is special and it needs to handle differently. The existing method which we are using needs to be adjusted and improved to suit the project requirement, and there are many agile methodologies presented in our daily models which are for Scrum, Crystal, Dynamics, or software development methods. Each method dictates how to handle the things, how to carry out day-to-day activities during software development so that we can deliver the quality product at the end. Now we'll see when and where can this model be used. So the requirements are changing every week, and it is obvious that this model main target is such requirement. Changing and scope tending projects on the second project, which has a tolerance to bugs or defects, than being used in building software fast and improving it greatly. So if you have any bugs getting reported, those are fine and will be fixed in the next iteration. And here the customer wants to make a decision by picking when they are looking at the product. Next, startup companies are the best fit here, where they need to make decisions based on the market conditions for small project with smart teams. Now let's take a look at the pros and cons of agile model. Let's begin with pros. Frequent customer collaboration, feedback and reviews. It can be faster in terms of delivery of the product. Third, flexible with respect to scope and requirement changes, for risk is minimized because of the requirement in the small task. The customer's early and frequent opportunities to look at the product and make decision and change the project requirement. Next, very much less focus on the documentations in this model. Talking about cons, using Agile, it is difficult to get an estimate and time for the larger projects. Second, the level of collaboration which involved in Agile model is difficult to maintain, but who are resource planning as deemed as and how long-term clarity on requirements and goals. Next, it is challenging to predict the cost, effort, and resources required at the beginning of the project. Fourth, poor fragmented output as team is working in nutrition and releasing it sometime. The complete output often becomes very fragmented rather than one cohesive unit. And lastly, there is no finite and as there is no clarity on long-term final outcomes, so no one can say when the project began and when it will end. So these were some of the pros and cons of using Agile model. Finally, we have come to end of the third chapter where we have seen the SDLC traditional ways and when and where to use them, pros and cons of those models. So thank you guys, and I'll see you guys in the next chapter. Hello guys, welcome to chapter 4, why DevOps. So let's quickly begin with this new concept. So the first question you'd be wondering about is, what is DevOps? How do you really define it? Thing is, as with most of the buzzwords around software development, there is no accepted definition of DevOps. The definitions vary from simple ones to complex definitions. DevOps can be defined as a combination of philosophies, practices, and tools that help an organization deliver applications at high velocity. This definition focuses on continuous delivery and guaranteeing correctness and reliability. Now, the complex definition, which is from one of the books called the DevOps Handbook, where the definition is split into 3 different topics. This definition focuses on the fact that DevOps is basically applying things which we learn from other areas like manufacturing, lean, and applying them to building reliable, stable, and secure software with less effort and cost. Now, instead of trying to focus or define DevOps, what we'll do is we'll understand how software development evolved to DevOps. The first few decades of software development was centered around the waterfall model. Waterfall model approached software development the same way you'd approach building a real estate project. For example, building an amazing bridge. So you'll build software in multiple phases that can go on for a period of anywhere between few weeks to a few months. You would do the requirements for a few weeks, you would do design for a few weeks, after that you implement it, and then you test it, and then you deploy it to production. In most waterfall projects, it would be months before businesses sees a working version of the application. While working in the waterfall model for a few decades, we understand a few key elements around building great software. So the first thing that we understood is the importance of communication. Software development is a multidisciplinary effort involving a variety of skills. Communication between people is essential for the success of a software project. In a waterfall model, we try to enhance communication by trying to prepare let's say 1000-page documentation or requirements, design, architecture, and deployment. But over a period of time, we understand that the best way to enhance communication within the team is to get the team together, get a variety of skills in the same team, and create cross-functional teams with a wide range of skills. The next element of building great software is automation. Software development involves a wide range of activities. Doing things manually is slow and error prone. We understood that it's essential to always look for opportunities to introduce automation. Now, the next key element in the building great software is getting feedback quickly. Building software is all about getting quick feedback. You cannot wait for months or years to know if you're building the right application. The business would want to know it immediately. If I'm implementing something right now, will it cause problems if it is deployed to production? You don't want to know it after a few months, you want to find it as early as possible. So the earlier we find a problem, the easier it is to fix the problem. So in this step, we realize that as with most buzzwords around software development, there is no accepted definition of DevOps. After that, we looked at three key elements to developing great software: enhanced communication, automation, and quick feedbacks. So that's all for this quick video. Next chapter, we'll be focusing on what is DevOps. Thank you guys. Have a great day. Hello guys, welcome to chapter 5. What is DevOps? So let's quickly begin with this new concept. So first one, what is the focus of DevOps? To answer this, the focus of DevOps is on enhancing the communication between the development and the operations team. How do we make developments of software easier? How do we make the operations team does more visible to the development team? Now, how did DevOps enhance the communication between teams? So the first thing DevOps did was to bring the operations team really close to the development teams. In more mature enterprises, development and operations team were combined into a single team. They started sharing common goals, and both teams started to understand the challenges the other team faces. And in enterprise, which are in clear stages of development or DevOps evolution, communication was improved by bringing representative from the both operations teams into the Scrum team and getting them involved in the sprint activities like stand-ups and retrospectives. So DevOps tried to enhance the communication by bringing the operations team as close as possible to the development team. The next question is, what are the automation areas where the DevOps teams focuses on? In addition to the focus area of Agile, which were continuous integration and test automation, the DevOps team were also focused on automating the activities of operations teams. So basically, the operations teams are typically involved in provisioning servers, installing software onto these servers, configuring the software, and deploying applications. DevOps teams are focused on automating all these steps. The key terminology around DevOps are continuous deployment, continuous delivery, and infra as a code. Continuous deployment is all about continuously deploying new version of software onto test environments. Continuous integration was focused on running the tests and the code quality checks. Continuous deployment takes it to the next level by adding deployment in the environment. In more mature organizations like Google, Facebook, continuous delivery helps in continuous deploying software to production. Now, in addition to running the tests, building the software and packaging the application up, the application is deployed to the test environments, and on getting the right approvals from your QA team, the software was directly deployed into the next environment up to production. The next focus area was infra as a code, all about treating your infra the same way as you treat your application code. It's all about creating your infra, that is servers, load balancers, databases in an automated way using code and configuration. To enhance communication, DevOps brought both the operations and the development teams together, and the focus areas of automation in DevOps are continuous deployment, continuous delivery, and infra as a code. Now, you might be wondering, how did DevOps help in getting immediate feedback? So to answer this, DevOps brings the operation and development teams closer because development and operations are part of the same team. The entire team understands challenges associated with operations and the challenges associated with the development. Any operational problem gets the quick attention of the developers, and any challenge in taking software live gets early attention of the operations team. So DevOps encourages continuous delivery and infra as code. Because of continuous delivery, if I make a code change or a configuration change that might break a test environment, then I would know it within a few hours, because infra as a code, developers can self-provision environments, deploy code, and find problems on their own without any help from the operations team. So in summary, DevOps is all about taking software development to the next level. It's about doing things which enhances the communication between the team, which helps you to get immediate feedback on any activity that you're performing, and automating as much of software development activities as possible. In conclusion, I see Agile and DevOps as two phases that helped us improve how we build great software. They don't really compete against each other, but together they help us build amazing software products. So this is the end of the chapter what is DevOps. So thank you guys, and I'll see you guys in the next video. Hello guys, welcome to chapter 6, DevOps Lifecycle. Let's quickly begin with this new chapter. DevOps defines an agile relationship between operations and development. It is a process that is practiced by the development team and operational engineers together from beginning to the final stage of the product. It is, learning DevOps is not complete without understanding the life cycle phases. So the DevOps life cycle includes 7 phases as shown in the diagram. It consists of development, integration, testing, monitoring, feedback, deployment, operations. So we'll take a look at each phase in detail in the upcoming slides. So let's begin with the first one, continuous development. This phase involves the planning and coding of the software. The vision of the project is decided during this planning phase, and the developers begin developing the code for the application. There are no DevOps tools that are required for planning, but there are several tools for maintaining the code. Second phase, continuous integration. This stage is the heart of the entire DevOps lifecycle. It is a software development practice in which the developers require to commit changes to the source code more frequently. This may be on a daily basis or weekly basis or a monthly basis. Then every commit is built, and this allows early detection of problems if they are present. Moreover, building code is not only involved compilation, but it also includes unit testing, integration testing, code review, and packaging. The code supporting new functionality is continuously integrated with the existing code. Therefore, there is continuous development of the software, and the updated code needs to be integrated continuously with smoothly with the systems to reflect changes to the end users. However, Jenkins is a popular tool used in this phase. Whenever there is a change in the Git repository, then Jenkins fetches the updated code and prepares a build of that code, which is an executable file in the form of jar. Then this build is forwarded to the test server on the production server. Moving towards the third one, continuous testing. This phase where the developed software is continuously tested for bugs. For constant testing, automation tools such as TestNG, JUnit, Selenium, etc. are used. These tools allow QAs to test multiple code bases thoroughly in parallel to ensure that there is no flaw in the functionality. In this phase, the Docker containers can be used for simulating the test environment. Selenium does the automation testing and TestNG generates the reports. The entire testing phase can automate with the help of a continuous integration tool called Jenkins. Automation testing saves a lot of time and effort for executing the tests instead of doing this manually. Apart from that, report generation is a big plus. The task of evaluating the test cases that failed in a test suite gets simpler. Also, we can schedule the execution of the test cases at predefined times. After testing, the code is continuously integrated with the existing code. Moving towards the fourth phase, continuous monitoring. Monitoring is a phase that involves all the operational factors of the entire DevOps process, where important information about the use of software is recorded and carefully processed, find out trends and identifying problem areas. Usually, the monitoring is integrated within the operational capabilities of the software application. It may also occur in the form of documentation files or maybe produce large-scale data about the application parameters when it is in a continuous use position. The system errors such as server not reachable, long memory, etc. are resolved in this phase. It maintains the security and availability of the service. Moving towards the fifth phase, continuous feedback. The application development is consistently improved by analyzing the results from the operations of the software. This is carried out by placing the critical phase of constant feedback between the operations and the development of the next version of current software application. The continuity is the essential factor in the DevOps as it removes the unnecessary steps which are required to take a software application from development, using it to find out if the issues are then producing a better version. It kills the efficiency that may be possible with the app and reduce the number of interested customers. Phase number 6, continuous deployment. So in this phase, the code is deployed to the production servers. Also, it is essential to ensure that the code is correctly used on all the servers. The new code is deployed continuously and configuration management tools play an essential role in executing tasks frequently and quickly. So here are some popular tools which are used in this phase, such as Chef, Puppet, Ansible, and SaltStock. Containerization tools are also playing an essential role in the development phase. Vagrant and Docker are popular tools that are used for this purpose. These tools help to produce consistency across development, staging, testing, and production environment. They also help in scaling up and scaling down instances softly. Above that, containerization tools help to maintain consistency across the environments where the application is tested, deployed, or developed. Also, there is no chance of errors or failure in the production environment as they package and replicate the same dependencies and packages used in the testing, development, and staging environment. It makes the application easy to run on different computers. Now, the seventh and final phase, Continuous operations. All DevOps operations are based on the continuity with complete automation of the release process and allow the organization to accelerate the overall time to market continually. It is clear from the discussion that continuity is the critical factor in the DevOps in removing steps that often distract the development, take it longer to detect issues, and produce a better version of product after several months. With DevOps, we can make any software product more efficient and increase the overall count of interested customers in your product. So we have reached the end of the chapter 6. So thank you guys, and I'll see you guys in the next video. Hello guys, welcome to the last chapter of this course, DevOps tools. So in this chapter, we'll be taking a look at two types of DevOps tools. First is tools required for monitoring DevOps, and the second one would be tools required for orchestrating DevOps. So let's quickly begin with this chapter. We'll take a look at a few tools in both the types. So monitoring is not at all a new concept, and we have been doing a lot of monitoring with various kinds of tools for monitoring the state and performance of our applications. So the couple of different types of monitoring and some tools only cover on one of those domains. The first type is infra monitoring. It focuses on the data related to health of your infrastructure, things like CPU usage, memory usage, network statistics. Now these are the things that are the tools for monitoring will do for us. There's another type of monitoring which is application performance monitoring. Now this focuses on the performance and stability of the applications that are running on your infra, and this will take a look at things like response time for web applications and also the application logs. So some tools cover both of these domains. That will focus on something else probably, but let's take a look at the tools that are good at infra monitoring. So the first one would be Sensu, which is designed as a modern replacement for Nagios. In fact, they have built in migration paths from Nagios to Sensu. So if you're currently using Nagios, Sensu is something that you might want to consider because it is much easier to migrate to it. Sensu uses a client server, a server agent architecture just like Nagios. So there's a shared central server and the agents are then installed on every host that performs the checks on each node of those hosts. Sensu, however, it is a little bit more modern and sophisticated than Nagios. It's more scalable, and the agents push data to the broker rather than just pushing them directly to the centralized server. Another tool that is very famous in the infra monitoring is New Relic. It is actually a SaaS or software as a solution, so their centralized server is located in the cloud. However, you must still install agents on each one of those services that you want to monitor. So your services are going to communicate through this agent to their cloud server to send data. So the New Relic supports a wide variety of metrics, and even though it's a good infra monitoring tool, it is also a good tool for application performance monitoring. The next tool is App Dynamics, which collects data points about application and presents them in a centralized dashboard. One of the benefits of App Dynamics is its code level diagnostics. Developers would love this. It's often able to identify the source of the problem or performance issues down to the line of the code that is causing the problem. AppDynamics also uses a server agent or a client server agent architecture with a centralized server and agents installed on each service. Now, we should also talk about New Relic here because that is also a good infra monitoring tool, and so does application performance monitoring. Lots of DevOps practitioners talk about aggregation and analytics, and aggregation and analytics are about what we do with the data once we have collected it. Most monitoring tools come with some kind of aggregation and analytics feature, but these are going to be the charts and graphs of the notifications that come out of your monitoring tool. So it is important to consider not only what type of data a tool is able to collect, but what features it has for allowing you to present and analyze the data. A great tool for aggregation and analytics is Stack. Stack allows you to pump data in, and through its aggregation engine called as Kibana, you can quickly aggregate and easily detect and diagnose problems. Now, there's some overlap between these tools. Elastic Stack also comes with agents, which it refers to as beats, which are able to actually collect both infra and application data to do both infra monitoring and APM, so nothing but application performance monitoring, and obtain the data, which Elastic Stack can be used to perform aggregation and analytics. But anyways, there are many different ways you can use the tools, but ultimately you may wind up using multiple monitoring tools in combination and in order to achieve your monitoring goals. Monitoring is so important for the success of your DevOps design, and at this point I highly encourage you to go ahead and take advantage of some of these monitoring tools. So moving ahead with the next type of tool, which is orchestrating DevOps tools. Now, orchestration means automation that supports processes and workflows, particularly the provisioning of resources. So orchestration let us do things like scale up, scale down an application or based on request, and that means assigning more resources to them or taking away resources when they are no longer needed. It also allows us to do things like auto scale applications based on usage, so we can actually detect increase and decrease in usage patterns and decrease in the, I mean, automatically scale up and down based on response. Orchestration lets you do things like create self-healing systems, so we can detect unhealthy nodes in a load balancer pool, remove them from the pool, and automatically replace them. One of the great orchestration tools that's available here is Docker Swarm. Docker Swarm is a Docker's native orchestration tool, and it is created explicitly for the orchestration of Docker containers. Basically, orchestration goes very well with the Docker containers because the containers are lightweight and self-contained, that could be spun up, spun down quickly. Now, containers are very efficient to use alongside orchestration tools that control when and how they spin up and spin down, and containers need to make orchestration easy. So if you want to do orchestration around Docker containers, Docker Swarm is a great way to do so. Another powerful orchestration tool is Kubernetes. It is called as a gold standard in the world of orchestration in DevOps. Kubernetes is an open source and it uses an orchestration server to control the orchestration of the resources. Kubernetes is able to manage your containerized apps across multiple hosts so that you have a pool of resources that may consist virtual hosts. The third important tool is Zookeeper. It is an open source solution developed by Apache Foundation, and Zoo can work alongside Kubernetes. It includes a centralized service registry, and much of its functionality is built around the concept. The services are spin up, spin down, and they register themselves with a centralized service registry, and that is done in order to help the services locate one another through the service registry. So that means the service registry will act as a center point for orchestration features, and the another powerful orchestration tool is Terraform. It is a tool that is a brainchild of HashiCorp. HashiCorp combines orchestration with the infra as a code. Now, some people think of Terraform as more of a infra as a code tool or configuration management tool, something a little more similar to Ansible. But Terraform is really built around the philosophy of orchestration, and that means that Terraform crosses both of these territories, but it's really focused on orchestration. Terraform really works well alongside other tools like Ansible, so you can use Terraform and Ansible together. It works really well with AWS and integrates with Kubernetes. So you can use Kubernetes to do high-level orchestration and implement a little bit more of the detailed configuration within the Terraform scripts. So we have reached to the end of the chapter and the course as well. So I hope you guys are now aware of the basic concepts of software engineering, software development life cycle, why DevOps, what DevOps, DevOps life cycles, and DevOps tools, all the 7 topics that we have covered so far. This is just a basic course on DevOps. And once you're thoroughly ready with the basic concepts that are shown in this video, then you can take up the advanced course on DevOps and keep learning.